All right, well, thank you, all 8 of you, for showing up. Appreciate that. We're going to share with you our journey from bringing chef automation to our Citrix environment. We're going to talk about all the challenges that we had and the technical solutions that we used to address those challenges. But really, it's more about bringing the chef development tool set to an uninitiated team that has very little development skills. So that's why the subtitle is Chef Development Pipeline for Noobs. I'm Scott Haley. I'm the manager of solutions engineering at Discovery. Basically, I think of myself as a cat herder. So I've got highly trained and opinionated engineers, present company excluded, that work for us. And a little about me, but not that you care. I started out in music, a degree in music, and then had a rock solid plan to be a rich jazz musician. And that didn't work out, so I had to have a career change, and I went into IT. Was desktop support for Windows for Workgroups 3.1, if anybody remembers that. Some of you are old enough to remember. I like growing things, that's me and my awesome tractor, and I like doing things and seeing things. Our team, solutions engineering team, we're focused on enabling development teams to do what they need to do, and we help provide tools for them to do those things. So that's stuff like Chef, Terraform, CI/CD suite, New Relic, Splunk, anything that will basically accelerate their delivery value to the business. Now, we mostly work with development teams in public cloud, but we'll work with any team that needs engineering solutions. For instance, like our Eurosport partners in Paris, we recently did a project with them for this was an AI/ML solution where they needed to do a bunch of language translations, or like 7 languages they needed to translate and then derive sentiment value from it. So stuff like that. We also have other teams that we work with to deploy apps on our Kubernetes clusters. Basically, we're mostly interested in integrating best practices into cloud platforms. We're an AWS shop. We have 95-ish accounts, I guess, probably 4,500 instances, somewhere around there.
Yep.
5,000. We're kind of just starting to get ramped up in GCP. Projects, I don't know how many projects we have, do you?
Not off the top of my head.
And then we're in Azure as well.
Everywhere.
Do I?
We're everywhere.
Everywhere. So we're Discovery. We are a global media company. We're the global leader in real-life entertainment. So either you or your mom or your girlfriend or whatever has watched some of our content at some point. Like Tyler and I, we are legacy Scripps. That was Scripps Networks, and then roughly a year ago, Discovery bought us. So that the whole suite is, HGTV, Travel Channel, Food Network, Discovery Channel, Animal Planet, the whole thing. So there's 8,000 hours of original programming every year. We're in 220 countries, 50 languages, 19 channels domestically, and 50 international channels. So although the focus over the past several years has been shifting to web-based apps, our Citrix infrastructure still has a really important role in delivering thick client apps. And it's not just the back-end office apps, but it's critical apps that have to do with delivering content. Our main line of business is just delivering content so that people can watch it. And so those apps might be something like ad sales, are super important. Scheduling apps, which is really complicated. Basically anything that's going to maximize viewership and revenue. That's what we consider really critical. And so our Citrix environment is exceptionally critical. And because of that, any change that we have to implement, particularly in production, we always face roadblocks from seemingly every direction. Tyler, I'll turn it over to you.
Yeah, so I'm Tyler Sorensen. I'm a cloud solutions engineer on Scott's team. I've recently moved into this role, big focus on automation tooling, but I've got a deep background in Windows Server and virtualization infrastructure, which is ultimately what got me assigned to this project. Personally, I'm an avid traveler. I love to go hiking. And if I'm at home, you'll find me gaming with my dog. He's a little bit of an oddball. He likes to lay by me and watch when I'm playing Switch. So let's dive into this problem that got us started on this path. So the Citrix team actually came to us with this statement that they're just too busy and they need some automation. It's just 3 members, so they've got a lot of work on their hands. They had a laundry list of items that they had in mind already, starting with instance configuration. They're spinning up new Citrix hosts constantly, and they want to help automate those configurations as they come up. Another idea they had to shift some of that work off themselves is enable some self-service for the service desk team so that they can do some troubleshooting, basic updates, things like that. They also wanted self-service for some of the software teams they work with. Citrix Zen App, by its very nature, is a shared platform, multiple pieces of software running on the same hosts, and they need to help coordinate. Those teams don't own the host, so they need to help coordinate and help those teams get it on to those hosts so they can do testing. So they need to coordinate schedules, and a lot of times those pushes happen after hours, weekends. It's kind of a pain. They've also got a mess of old scripts, and it's kind of all over the place, batch, PowerShell, and they just want to take it all instead of dragging it along and convert it into a more modern configuration management tool. Also, they've got a lack of alerting right now for if the current scripts don't do what they're supposed to. They really don't have an idea until a user calls up and says, hey, my app's not launching. So they need some alerting for that so they can be more proactive. Also, with Citrix, they're dealing with a lot of different base images across the multiple environments they're working with. Right now, it's a manual process to crack open those templates, make the changes, push the updates, Windows updates especially. So they want to automate that process as well. And here's the big one. They want a one-size-fits-all solution, something to solve all these things in one fell swoop. So the overarching theme is they want to modernize and automate everything possible, but not having any of the background in automation or development. They're not sure why, or how to get to the endpoint. It just sounds good on paper. They know they're busy and they need some help. So that's where our team comes in to help bridge that skills gap, create those processes and workflows and best practices to put that stuff in place. We did decide to break down that list and start with the first item, instance configuration, which has been Chef's bread and butter for a long time now. And you'll see that that's got a lot of direct ties into solving the other issues for us. Scott.
All right, so I'll talk about the Citrix team itself. So they're a talented team. They know Citrix top to bottom. They're super focused on their apps, and they're particularly interested in the user experience of their apps. As Tyler mentioned, they've got some scripting experience, but it's just batch and PowerShell. And none of the scripting is run through any testing or version control. And so anytime they make changes, it's usually through the GUI. They're Windows guys, and it's GUI or ad hoc. And because Citrix itself, where it sits in the application delivery, because it's really important, they're really usually very busy with their users. They spend a lot of time triaging tickets. If you work in Citrix, you've probably seen a ticket that says Citrix is broken, which generally doesn't mean Citrix is broken. It's always something else, right? It's the network, it's the database, there's something else. And even though you don't have control over the other dependency or the upstream thing, you're still responsible for it. And so that's what these guys are facing. They're very busy, and so we had some concern about, with Chef, we had to throw a lot of new tools at them just to get Chef up and running. All right, so let me shift to the environment. We have several different environments, on-prem, cloud. In both cases, it's spread across European and US regions. There's separate controllers for both dev and prod. So that's 10 environments, and then remember there's only three members on the Citrix team to support that. Now, within each environment, there were automation attempts, like for on-prem, they use Citrix Provisioning Service to stand up instances. In AWS, they use MCS, Machine Creation Service. A majority of all the configurations are baked into the base image, but maintenance of those base images is a manual process with a post-boot script. And that script is where things kind of get interesting. So we have a script that calls another script that calls another script that may or may not do anything depending on what host it's on. And sometimes there'll be configurations, some won't get the configurations even though they're in the same machine catalog. The script itself, there's entire sections that are commented out. There's references to servers that don't exist anymore. And all of it's written in a combination of Windows command line, PowerShell, there's probably even VB script in there. And all of this is stored on a share with no version control. So if something breaks, it's really difficult to troubleshoot it. Oh, actually, there is version control. It's a Word document. And so basically they write down what the changes are with each version. So but it's impossible to duplicate that, if they need to do it from scratch. So anyway, with all of this in mind, they have weekly, change control meetings. They discuss the changes, they approve it or they don't approve it. And if they do approve it, it's usually applied over nights and weekends for production. I mean, this sounds overly negative, but probably all of you can identify with it on some level. And so, what it comes down to is when they do these changes, the only thing they really have time to do is like limited cleanup and then just making sure that the stuff keeps running. So our goal, the ultimate goal, was basically to move them into a more controlled release pattern. Just try to get away from breaking changes. Try to get them away from night and weekend work. When I go home, I want to go to my happy place, and there's no place for Citrix, no room for Citrix in my happy place. So some of the challenges that we wanted to address. Number one, speed up delivery. It's super cumbersome. I mean, anytime there was a change, they had to change the base image. Number two, we wanted to optimize the Citrix team's time. So basically, they're doing these super repetitive tasks. We wanted to get that out of the equation so that they could spend more time innovating. That's what we all want to do. Number three, so we wanted to shift our approach and lay the groundwork for more advanced development. So, we also didn't want to overwhelm them. Now, with the Chef ecosystem, I mean, I'm not a Chef developer, I'm just the dumb manager here, but when I look at it, it's overwhelming. I mean, there's just a plethora of terminology, there's all the add-on tools, and so you can imagine for this team, it would be pretty intimidating for them as well. And then the last thing we wanted to do was to throw them in the deep end of the pool and have them start, writing recipes without any guardrails in place. Number four, enable the team to grow and learn. Remember I said earlier that our team is basically, our main goal is to enable teams. And when I say enable teams, I don't want to take work from them and do it. I don't want our team to do it. I want to enable them to do it. So part of this process was they had to learn. They had to grow into that tool. And then finally, we wanted to use this example as a success to foster adoption. What that means is this was our first crack at a Windows group. So it was important for us to be successful so that other Windows teams, might adopt, the same process for them, and there would just be faster adoption. Tyler, I'll hang back over to you.
Okay, so yeah, with this wide array of issues we're trying to resolve, you might be wondering why we decided to go with Chef. I mean, this is a Chef conference, so you assume that's what we did. But there's definitely a lot of options in this space. So first of all, for us, it's got that great cooking-related theme. We've got, Food Network cooking channel. I think we're pretty much obligated.
Yep. Mm-hmm.
Yeah. So, Chef, recipes, test kitchen, it's perfect. But we did already have a large internal install base in our Linux environments across on-prem and cloud. So it had a major win there, so we could leverage existing resources and past lessons to get the Windows environment running faster. Outside of those personal biases, Chef's got really strong Windows support. It's only gotten better with them being brought in as native resources. You no longer have to bring in the Windows Cookbook like you used to. So some great stuff there. It also can run locally on Windows. There's some tools out there that can't do this and require, WinRM connectivity, which can usually be a pain, especially in large environments, to get that set up and actually secure, not just going in and turning off SSL connections in WinRM. And lastly, Chef's got an awesome ecosystem and a great community, and with that comes, full testing capabilities and packaging suites that a lot of other tools don't have, or sometimes we'll even leverage, Chef tools like Test Kitchen. So having those native tools and being able to do a test-driven development workflow was our main goal. So we mentioned we've got some previous Chef use in the environment, and it kind of followed a strict divide between traditional infrastructure and our cloud-native deployments that follow the pets versus cattle model. So we needed to determine where Chef was going to fall, or the Citrix infrastructure was going to fall in this design. So with our traditional infrastructure, it's being managed by Chef Server, continuous management, any updates are being pushed through. It's got that constant control. On the cloud native side, we've opted to use Chef Zero because those environments are rebuilt very frequently. We don't need that constant contact with the Chef server, so anytime we need to push a change, we just delete it and rebuild the stack. I think everybody would rather be on the right side, but Citrix, it's got a lot of user state and things like that you need to worry about, so you might kind of skew towards the traditional infrastructure side. Ultimately, though, we did go with the Chef Zero approach, and I'll talk a little bit about that. So we chose to go with Chef, but we're not just leaving them at it to start writing recipes. It's kind of dangerous territory. I think you'd end up in a bad spot if you just let them loose. We needed to assemble a set of processes for testing and packaging and actually getting this stuff to run in the environment. And as we approached this, we always kept the KISS principle in mind. I'm sure you've all seen this before, but it's keep it simple, stupid. Not because we're dealing with stupid people, far from it. But anything we go after, any type of solution, we try to design it to be as basic as possible. And this fulfills 3 goals for us. First one, we want to make sure we improve adoption. If you make some big, complicated spider web mess of tools for them, they're probably just going to go back to the safety of what they know and are used to. So we want to make sure that they're actually able to adopt the solution. Also makes it easier to support. As we said a couple times, we don't want to take over that work. We want to quickly transfer the solution off onto the team so they can start managing it themselves. Also, we don't want to be the guy that owns everything. We want to make sure we democratize those tools and get it out to the Citrix team and other teams as well. Lastly, it's easier to move. The more complicated you make it, the more difficult it's going to be when you need to migrate it somewhere else. In this case, we're running this all on top of Jenkins, which we have a love-hate relationship with. So if we decide to move to another CI tool down the road, we want to make sure that it's portable. So at a base level, the Chef ecosystem can be a little intimidating for newbies. I shared this slide with our Citrix team as we started down this path, and there was just kind of a long pause of silence, and I could feel the panic and terror setting in as they're realizing how much they'd have to learn, what they're getting themselves into. But we didn't leave them with that. We pointed out that while everything here is very important, they just needed to learn recipes, cookbooks, some simple Git workflow, and a little bit of test kitchen to get started effectively. And we were going to take care of a lot of the rest of the pieces and help them get up to speed with them as they felt comfortable. So as we got started, we did focus on the cloud environment. Reason for this, it's a much newer, cleaner environment. It's a lot simpler as it stands right now. And more than likely, it'll be the final destination for our Citrix rollout. So we didn't want to have to re-architect everything. We wanted to kind of narrow our focus. As I mentioned, we did decide on that Chef Zero deployment strategy. The reason for that is we are using those automated tools to provision our Citrix hosts, PVS and MCS, and they rebuild our instances as often as every day and at the very least once a week. So they are pretty short-lived and do skew towards that cloud-native direction. Added benefit of this is they didn't have to learn knife commands or figure out how to work with the Chef repo. So that made the learning curve a little shorter for them as well. If anybody hasn't used Chef Zero, it is the local mode of the Chef client. It's enabled with the -Z parameter there, and then you would supply a cookbook or recipe run list. And then we're also supplying in our case, a recipe URL, so it can pull our cookbook package directly from in this case, S3 object store. So it's pulling that down. We don't have to download that ahead of time. To simplify the interaction, we put as much as possible into the pipeline to offload any work from the users. And that minimized the number of commands they needed to actually learn to work with Chef deploys. So they do need to know how to generate new cookbooks as needed. So they need the chef generate command. Obviously, they'd also want that, to create any other pieces of the cookbook. There's also the Git workflow, which at the very least they would need to be able to clone, do their commits, and push up to the origin. And then we did recommend that they learn some of the testing tools, but we actually found a pretty decent way to wrap that up so they can run them all with one command, and they don't need to even actually learn those. And at the very worst, if they are really scared of running tests because they're not used to that, it's always going to run it in the pipeline. So there's always that base layer of testing that's going to happen regardless of what they do. We also made the decision that we're only going to build on master, and we allowed them to push directly to the master branch. And you might not like that. That's probably not how most of us would work, but it simplified the number of Git commands and their understanding of Git. Surprisingly, though, we thought this would make it easier, but they were really excited about branching and pull requests. So after a week or two, they actually dove into that. So in our S3 object store, where we're actually throwing our finished cookbooks, we've got a simple folder structure where, separate folder for each cookbook, and then underneath we are storing a copy of every version. S3 storage is cheap, and these cookbook files are pretty small, so we can keep a bunch of different versions if we ever need to roll back. On every upload, we do also copy into a folder for the latest version, and that way we can pin that directly to our test environment, so they're always picking up the latest code. All this gets packaged up in a tarball using Burkshelf. So I mentioned we're using Jenkins for our CI tool. Jenkins is another scary tool for beginners to development. So we wanted to avoid pushing too much of that onto them. We used Jenkins shared libraries so that we could store the actual pipeline in a shared location so they didn't have to copy a Jenkins file between every single cookbook repository. This avoided that duplication, following dry principles, don't repeat yourself. And then the Jenkins file that actually goes in the cookbook repository is just this little piece here. So it's very short. They've got a library identifier that points to the GitHub location where they're pulling the actual pipeline from. And then the only thing that would change from repo to repo is the two parameters for the name of the cookbook they're building and then the S3 bucket location that we want the final package to be dropped in. What that ends up calling is a Groovy pipeline script, which we just broken into some simple stages. And this too is very simple. We wanted them, if they felt comfortable, to be able to dig into this and learn more about it. But we're just running some shell commands that are calling a make file, which you'll see on the right there. And make is just the wrapper around our chef testing commands. So we're running linting, unit, and kitchen tests, or integration tests for kitchen. We'll talk a little bit about the testing in a little bit. So our CI workflow ends up looking like this. The users only have to deal with the left side of this equation. They're doing some development, hopefully some testing locally, and then as soon as they feel comfortable, they would make their commit, push it up to the origin, and then Jenkins is going to take over and do the rest. It's going to run through all the tests, and assuming that everything looks good, it's going to package that up with Burkshelf and dump it in that S3 bucket. That automatically is going to go to our test environment, and then as soon as they're happy with how it looks in test, they would increment the version number for QA and then prod. So, cookbooks themselves, these can also be scary. You run the chef generate cookbook command, and it creates dozens of files by default, which if you're just getting started, you really just care about your recipe file. So you're wondering maybe what all the rest of this is. But there are a few other files that we wanted them to be aware of, at least as they're getting started and familiarizing themselves. The big one is the metadata file. We're tracking our version number in there, and that's really the only way that a new version gets uploaded into S3. So we have a safeguard in place that if they don't update the version number and the metadata, It's just going to stop the build process at that point. Also, we encourage them to use the changelog and the metadata so they can start actually having some documentation and tracking within the repo itself so they can communicate with the other team members they're working with. Obviously, another important file is the recipes file. That's what they're going to use to actually do real work, what they actually care about. And then I mentioned they do need to touch the test kitchen config just at the initial creation of the cookbook. This can essentially be copied and pasted between projects, but this just configures the EC2 driver since that's where we're deploying to. We want it to deploy into the same environment that it's actually going to be deployed in prod. So I've got a quick demo of what this workflow might look like. So we are running this in Jenkins on top of Kubernetes, so just for simplicity's sake, I'm taking that same container and running this in a local Kubernetes deployment I have, but this is totally not necessary for your standard user. So if I go into my cookbook directory, oh, and maybe, sorry, I'm dual screening here. So first of all, they probably wanted to change something. Not a very exciting recipe here, but say they're done testing, they need an application directory. So they make their change, and they want to do a quick test. Oops, sorry. Let me clear this up here. I need to get in the right frame here. There we go. Okay, so they type in make, and that's going to kick off all the tests that we actually run in our pipeline. So assuming it passes locally, it's going to pass in the pipeline as well. Reason we want to do this is we don't want them just pushing commits up to the repository, just trial and error until it works. We would like them to do some testing locally. What that make command calls is, as you saw, our different testing protocols. So we are using cook style, which is doing our Ruby and chef-specific syntax checks. This can be a little heavy-handed for new users, but it's been a really good way to keep things from getting out of hand and keeping things clean as possible. We're also using Food Critic, which is just making sure that they do some basic updates to the metadata and the README files instead of just leaving those blank or default. And then we're moving on to our unit tests with chef spec. By default, the chef generate command creates some tests for you, but they do literally nothing on Windows. So we're just leaving that in there so that it's always going to run regardless. And then when they're comfortable, they can go back in and add those unit tests. Now you can see we're kicking off our test kitchen run, which is deploying our Windows instance. In a production scenario, it would be deploying the actual Citrix AMI, so we're testing against something real. And then running our cookbook, so you can see it made sure that resource was up to date. I'd already run this earlier, so it didn't need to make the change. But cookbook ran successfully. And then we're also running kitchen verify, which is going to kick off our inspect tests. Again, the default inspect tests do nothing, but we've left it in there so that when they're ready, they can build on it, and nothing needs to be changed in the pipeline. It's just ready to go. So everything succeeded. Awesome. We're going to, before I make more changes to my file, we're just going to add that to our commit. And we changed our directory. And we're going to push that up to our origin. And after that, it's hands off for them. So they make their change in the cookbook, run make, do their commit, and push it up. And that's all they need to do locally. All right. So up to now, we've been talking a lot about simplifying a development workflow for beginners, but we did actually run into several obstacles that were specific to the way Citrix implements its cloud deployment. They've abstracted away a lot of the public cloud features that we use all the time, and I think they've done this to make it more accessible to people that aren't familiar with cloud, but it's really been a pain for us. I've opened feature requests with Citrix on a lot of these things, but I'm not exactly holding my breath, so we came up with a number of workarounds. First big one is they don't expose the instance roles setting. Normally we would use this to authenticate to AWS resources. In this case, the big one is our S3 bucket where we're pulling that cookbook down from. Because we don't want to open that up to the internet, we want to make sure that that's secure. To get around that, we took the easy way out and set up S3 bucket rules based on source IP. We know the IPs that all of our Citrix instances are coming from, so we just whitelisted those. It's not exactly my favorite solution, so if Citrix doesn't get that implemented sometime in the near future, we've talked about using an event trigger to automatically add that instance role anytime a Citrix instance gets spun up. There's also no access to user data, which we use a lot to specify the Chef client run for new instances we're spinning up for our cloud native builds. Our way around this was pretty simple. We just created a scheduled task that runs at boot, and we embedded this in our Citrix AMI. What that's doing is retrieving our Chef client run script, and then it's just executing it. The reason we didn't just put the Chef client command directly in our scheduled task is we want to be able to do things like update the version that we're running, make changes for the different environments we're running in. So this allows us to make that change in a remote location, and then it just gets pulled down instead of having to update the AMI every single time. Also, no tags. We love tags, and a lot of times we use that for specifying things like the Cookbook version we want to run or the Chef client version that we want pinned. So we would just pull that from metadata. Because we don't have that, like I said, we're putting that in the remote script, and that's just set up as a PowerShell variable. And then we have some logic built into the PowerShell script that sets the variables based on the environment, so prod gets different versions than QA. The Citrix team did say a big thing for them is they want to be able to do some alerting. This actually was really easy. Chef takes care of this pretty nicely for us. Because we're using Splunk, we can pick up our Windows event logs and alert for errors there. The Chef client does, by default, do successes and failures directly to the Windows event log, so the work was pretty much done for us. We just need to set up those alerts. But we did want some additional logging so that we can do troubleshooting if there are failures. And we did this by, again, a piece of PowerShell to set up the client.rb file that the Chef client uses for its configuration. And we're just specifying the log level and the location for that log. So lastly, we've got all these pieces put together. We've got our workflow. We've got all our Citrix issues resolved. How do we actually get this running? I think many of you might agree that trying to convert all of our old scripts overnight into Chef native resources is probably not a good way to go. So to get these things to coexist, we had Chef manage everything. So we're kicking off the Chef client run, and then we're using a PowerShell script resource to call some of those old scripts and kick those off. This could also be done with something like an execute statement, depending on what your script scenario is. It's important to note that this is not going to be idempotent, so anytime you do the Chef client run, it's just going to execute this over and over. So you'd either want to put in something like a guard, or in our case, we're only running it at boot, so that's our resolution. So the question is, has this approach been successful? I'd be lying if I said there wasn't some pushback. This is very different for them, definitely outside their comfort zone. They were just getting used to scripting with PowerShell, and now they're shifting onto something else. So the question came up, aren't we just going to have to change tools again in a couple years? And that's a definite fear, although we love Chef, and I think we're in it for the long haul. It's not so much to focus on the tool. I think the big benefit here is the workflow overall, that they're moving from something that's not being tracked or tested into something that's a little more stable and predictable. And the other benefits they're getting out of it is that built-in documentation, the versioning, they've got a lot more control and visibility into the environment by going this route. So we tried to emphasize that, and it's really started to catch on. And it's important to note, hand-holding is going to be required anytime you do a major shift like this. So we did a lot of training with them and gave them a lot of resources to get them going. So what's next for us? We've got this running successfully in production today, but we want to continue translating those old processes and scripts over to Chef native resources. We're also going to circle back and tackle those base images using a Packer to build those out, but we intend to use the Chef provisioner that's built into Packer so we can still use those same testing processes to do our configuration and use the same type of syntax. We're also trying to steer them away from those ad hoc changes like they're talking about with the service desk teams and the software teams, and either get those software teams involved writing Chef, or help them get Chef client running on like an interval so it'll automatically pick up any changes to the software repo. And lastly, we're going to evangelize. We're going to get this out and show other teams, the kind of benefits they can get from using this. I want to thank you all for joining us. Any questions? Yeah.
Could you give me just a high-level overview of what it would look like to automate updating
Yeah. Yeah. Yeah, so the question was a high-level overview of trying to automate creating base images with Packer and Chef. So again, we'd use a pipeline like this, and you would specify your image build in Packer. If you haven't worked with it, Packer is totally focused around building base images. And it's got different drivers for different environments, whether you're in AWS or running in VMware or something like that. So it'll spin up an instance, either from a base image, or if you're doing it on-prem, you might want to boot from an ISO, and it'll create that VM. And at the base level, once you've got your OS up, it'll connect to it and then execute any configuration scripts. In our case, there's a Chef provisioner add-on that you would use Chef to copy over Cookbook and then do your configuration via Chef to that image. Once everything's done, it's going to shut that image down, create an image of it, and store it as an AMI in our case, or VM template, or whatever the case might be. Yeah. Anyone else? Well, thank you.